So what comes next? After we've done combinations, the next thing is composition of functions. So just like we did before, let's do a definition before we actually try to do anything else. So this is going to be, again, for two generic functions, f of x and g of x. So our notation is going to be f circle g, so like this tiny little circle, looks kind of like a little O. Sometimes people just call this fog. So this means f of g of x. So if you actually say that out loud, so it's f of, right, which means so f of kind of indicates for us to do a parentheses. So in the parentheses is going to be g of x. So f of g of x. The other version, if we sort of reverse the roles here, if I do g circle f of x, g of f of x, so that's g is my kind of outer function, so of, well, of what? F of x. So what I'm doing, right, is I'm taking one function and I'm using it as an input into the other. So I'm, I guess this is where the name comes from. I'm sort of composing them together. I'm not just like multiplying them together or adding or subtracting. I'm actually sort of using the kind of input-output function properties, right? Normally we sort of input a number value. We put it through the formula and we get a number out of it. But in 2.1 we did this kind of thing, right, where we sort of had a function formula and we input not just a number, but we input like some short algebra expressions. We did things like f of x minus 2, right, f of negative x. Those are technically going to be composition of functions, even though we weren't talking about them like that at the time. The easiest way, I think, to wrap your head around this is really just to sort of see it in action. So let's recycle the functions we just were using. So let's say f of x is the root of x minus 4, and g of x is, what did we call it, x squared plus 3. So let's find these two compositions. There's aspects of the domain that like change. It's a little more complicated. We're not going to get into it right now. We can talk about the details of it some other time, maybe. So let's find these two compositions. So f of g of x and g of f of x. So shift this up, we'll get a little more room to work with. I'll do one first, we'll sort of take it down, and then we'll compare it to the other version. So first things first is really just rewrite it exclusively using our parentheses, right? So f circle g of x should be f with g of x in our parentheses. So then you sort of start to say, okay, so what is g of x equal to, right? What is our g of x? Well, g of x is x squared plus 3. So what this becomes, right, is f, and then in our parentheses, right, the input is going to be the other formula, the other function, x squared plus 3. So the idea here is I'm taking my f formula, right, my sort of f expression, the root of x minus 4, and for the x in there, right, what I'm going to input is my other expression, x squared plus 3. So it sort of starts to look like f of x squared plus 3, right? So my f formula, if I keep this going, so that should be the root of, right, quantity minus 4. So what is the quantity, right? What's going in? What's replacing the x? Well, in this case, now it's x squared plus 3, right? It's whatever was making up our g of x formula. Once we have that laid out, it's really just a matter of then sort of saying, okay, can we like simplify this? Can we clean it up? Can we do anything here, right? This is going to be just sort of x squared plus 3 and then a minus 4 tagged on the end. There's not a whole lot to do here. This would just be, okay, so plus 3 and minus 4 is just going to leave us with a minus 1. So our final version here is going to look like the root of x squared minus 1. Nothing more to do. I mean, if for whatever reason the numbers fully canceled out, if this was like a plus 4 and a minus 4, for example, and we were just left with x squared, well, then we could do a little more. You could take the root of x squared and get all the way down to an x. That would be kind of cool. But that's not what we have here. We have something a little bit different, nevertheless. If we do the other version of this, so if we flip our roles around, right? So this is g of f of x, right? So this is now g as my form, right? And what I'm putting in to the g function is whatever my f of x formula is, right? So in this case, that's this root of x minus 4. So I'm just sort of copying and pasting essentially, right? So what is f? F is this, so I'll replace that in here. So what does that start to look like based on my g formula? So it should be that whatever's in my parentheses, I'm going to square it, right? So my g formula is supposed to be, right, x squared plus 3, right? Whatever goes in for x gets squared, and then I add a 3 on the end. What's subbing in, right, is this root of x minus 4. And then you say, okay, well, this is actually a little bit even sort of, I was going to say cooler. I mean, that's just because I'm a nerd, right? But this is even more cool than what we did before, because if I do square root and then I square it, the square root and the square will cancel each other out, right? So this is a little bit more math action, which is why I'm excited. So this square root and the square cancel out. We're going to add this 3 on the end, right? This just comes down. And so my final version is just going to be, so x minus 4 plus 3 is just going to be x minus 1. So that one simplifies and cleans up a little bit more, right? The basic idea, right, is so I'm composing these two functions together. I'm sort of using one as an input into the other function. Gets me some more interesting things happening rather than just adding, subtracting, multiplying, dividing, right? I get a little bit more kind of interesting math stuff potentially.